All right, homework questions on section 3.5. Here is our function of interest. Okay, so first glance here, we have a quotient, so we should apply the quotient rule. And the quotient rule for f prime of x, for any function, says take the derivative of the top first. So the derivative of the tangent is the secant squared. Derivative of -2 is 0, so we just have that as the derivative of the top. And then we have to multiply that by the bottom. So maybe I'll do the bottom. All right, and then we subtract the derivative of the top. So we're not going to mess with that, so we'll just write that in blue. Tangent of x, oops, -2. And then we multiply by the derivative of the bottom, and the derivative of the secant is the secant tangent. All of that is divided by the denominator squared. So that would be the secant squared of x. So that's the problem at first glance, and then we got to clean it up and see what happens. So I think we're going to have to distribute here. And so not only does the secant tangent need to be distributed, but the minus sign applies to both of these also. So that's going to shake things up a little bit. Remember, you need to practice cleaning these up. So I guess we'll write the first part as secant cubed of x. And then we're going to have a minus tangent times secant tangent. So that would be secant tangent squared. So that covers that. And then minus -2. So that would be 2 times secant tangent. All of that is divided by secant squared. All right, so for sure we can factor a secant out of everything in the top. Is that the best strategy? I don't know until we try. So we try. So there's a secant in every term. We factor out a secant. And that leaves us secant squared of x minus tangent squared. Ooh, that's ringing a bell. Of x. When I see squares of trig functions, I think that Pythagorean identity. So the secant's out, and then we have plus. We took the secant, so we have plus 2 tangent of x. And all of that is over secant squared of x. And so since we factored that secant out of the top, I think it's now safe to say secant divides into secant squared, leaving just a secant in the bottom. And then in the top, let's double check Pythagorean identity. I think this is 1 or -1 maybe, but it could be way off. I always remember the sine, cosine one, but I forget the choose up book. Let's get some quick identities. I forget the tangent secant identity sometimes. Let me answer questions right now, please. And so in the appendix, a review of pre-calculus, they have trig identities, and I want Pythagorean identity. I should have it here somewhere. They don't have it. Okay, so we'll have to derive it from, or just look it up. Sine, cosine, might as well derive it. Good practice for you guys. Oops. Page So let's see, I know that sine squared cosine squared equals 1, and so to convert this into tangents and secants, tangent is sine over cosine, so I divide everything by cosine squared. All right, so then that cleans up, right? Sine over cosine is tangent, so that's tangent squared right there. Cosine over cosine is 1, and then 1 over cosine is secant, so that equals the secant squared of x. And if we bring the tangent to the other side, then 1 is the secant squared of x minus the tangent of x, tangent squared of x. All right, so what do we have here? We have secant squared minus tangent squared. Yeah, so this thing right here is just 1 according to that identity. So things are cleaning up nice. So this is equal to 1 plus 2 tangent all over secant of x, which is a lot simpler, kind of similar to what we started with. So let's see, did we get that right? Did we mess anything up? Derivative of the tangent is secant squared times the secant minus tangent squared minus 2 times the derivative of the secant, which is secant tangent. That looks good. Factored out a secant, canceled. Pythagorean identity here says that's 1. Can we make it any simpler than that? That looks pretty darn good, but the only thing that comes to mind is to rewrite this in terms of sines and cosines and see if stuff cancels. So just for a little trig practice, this would be 1 plus 2 sine over cosine. Sometimes things clean up this way, sometimes they don't. And secant is 1 over cosine. So that would be multiplying the cosine into the top. Right? So dividing by a number is multiplying by the reciprocal. So that gives me that. And then if we distribute the cosine through here, we get a cancellation here. So what do we get? We're going to get cosine times 1 plus 2 sine. That is simpler. There's no denominator. So let's see what the homework system says about that for me. Will it take them both? Let's try. So first time fraction, I have 1 plus 2 tangent of x divided by the secant. Did I type that correctly? 1 plus 2 tangent over secant. Likes that one. Let's try the other one. The other version, cosine of x plus 2 sine of x. Type that correctly. No. Oops. Oh, I accidentally hit the power button. That'll mess things up. And it likes that one too. Cool. So one thing I might encourage you to do is when you're cleaning stuff up, see how many different answers you can get the computer to take. Now, after your third one, it says, okay, you're done with this problem, and it gives you a new one because I have it set to do 3 tries per problem before it regenerates a new one. So at most, you can check 3 different answers at once. So like this crazy red one right here, it might take that one too. That's not at all simplified, so I'm gonna leave it, but challenge yourself. Let's see, Cole, isn't 1 plus tangent secant squared? No, it isn't. It's, if we look back at the identity here, it's 1 plus the tangent squared is the secant squared, and without the squares, we got nothing. And we don't have a tangent squared back here. What are you referring to this part right here, Cole? Yeah, okay. Yeah, so we can't clean that up because that's 2 tangent, not tangent squared. But you're right, if that was a tangent squared, then we could replace that with secant squared and it would clean up a lot. And if you're like hesitant to check like here if things work because you're worried about getting something wrong, it's the homework. It's no big deal. You can always do it again for full credit. On the other hand, you could graph the things and see what they look like. So whip out Desmos or GeoGebra and graph the things you think are equivalent. For example, first I graphed first I would graph my first answer, 1 plus 2 tangent minus the 2 divided by secant. So there's that one. And hey, that looks kind of like a sine wave or a cosine wave. And then we compare that to the other version we had, which was the cosine of x plus 2 sines. And I can see that they sit right on top of each other. See it changing from green to blue there. All right, cool. Number 10, moving along. Multiple derivatives. Oh, I'm so glad you asked about this one because this is like one of the cutest problems ever. I'll show you why. So let's see, we're starting with cosine there, right? And we want to find multiple derivatives. So starting with f of x equals the cosine of x, we're going to find multiple derivatives. So next, let's do the derivative of the cosine. And this is one you should really memorize. That's the opposite of the sine of x. And remember, all co-function derivatives are negative. It doesn't matter whether it's cosine, cotangent, cosecant, they're negative. Opposite of some other functions. So that's f prime. F double prime. Well, what's the derivative of the sine of x? Well, we got this negative tagging along out front. Derivative of the sine of x is the cosine of x. Okay, what's the next derivative? Well, take third derivative. Take the derivative of what you see above. Well, we get the negative hanging out, so that goes there. Derivative of the cosine is the negative sine. So I get the opposite of the sine, which is the sine of x. And then if I take it a step further and find the fourth derivative, derivative of the sine is the cosine of x, and I'm back where I started. Check that out. And you know what this reminds me of right here? I, right? Think about I, and then let's actually go I to the 0 power is 1. I to the first power is I to the second power is negative 1 because the square root of negative 1 is I to the third power would be I times I squared, which is negative I, and then I to the fourth power would be negative 1 times negative 1, which is 1, which puts me back where I started up there, and then this just cycles again. And it turns out powers of cosines, derivatives of cosine cycle. So if somebody asked, hey, you know, I really need the 20th derivative of the cosine, which I would write like that, little parentheses with a 20. You could put Roman numerals there too, is another way it's written. So let's see, the 20th derivative. Well, the first derivative was negative sine, the second was negative cosine, the third was sine, the fourth was cosine, the fifth is going to be negative sine, right? It keeps cycling through that. So if I take 20 and divide by 4, because the cycle is of length 4, that tells me 5. So that means the, let's see, and then there's remainder 0. So that means it's going to be like this one right here. It's going to be equal to the cosine. If somebody says, hey, find the 6th derivative of x, and that's f of x right there. The 6th one, 6 divided by 4 is 1 remainder 2. And so that would be like the second derivative, negative cosine of x. And we could see that would happen here. This one's the 4th. The 5th one would be negative sine. The 6th one would be negative cosine. Right? So the cool thing is derivatives of sine and cosine are predictable. So just like the cosine has a cycle of 4 and its derivatives, the sine also has a cycle of 4 since they're so intimately related. All right, that was fun. Other homework questions? Certainly. Okay, so good, a tangent line problem. I was hoping somebody would ask about one of these, otherwise I was going to do one. Find the equation of the tangent line to y equals 8 sine of x at the point pi over 6, 4. So this really isn't any different than any other tangent line that we found. Copy the relevant information. And do it. The only weird thing about this problem is it asks for m and b separate instead of an equation. No big deal. We got this. All right, so tangent line. So first thing we have to do is to find the slope of the tangent line. Oops. There we go. That is just the derivative. So derivative of 8 sine of x, the 8's just a constant, it hangs out. Derivative sine is cosine of x. And then we want to evaluate that derivative at pi over 6. And so that gives me 8 times the cosine of pi over 6. And let's see, whenever I think sine and cosine, I think the unit circle here is pi over 4, pi over 3, pi over 6 is this little one over here. And cosine is the x value there. And hopefully you remember that's the square root of 3 over 2. So this gives me 8 times the square root of 3 over 2, which is 4 square root of 3. So I do expect you to know trig functions of special angles and not just plug that into a calculator. So that's something I expect you to know from your trig days. Then I know the point slope formula, y minus y1 equals m times x minus x1, so we just plug in and write y equals. So y minus 4 equals 4 square roots of 3 times x minus pi over 6. And we have to solve for y, so distribute 4 square root of 3 times x minus 4, oops, it's not 4, it's the square root, there we go, times pi over 6. And then we get to add that 4 to the other side and clean this up a little bit. And it doesn't clean up too much. 2 goes into 4 twice, 2 goes into 6 3 times, and that's about all I can do. So I have a slope of 4 square root of 3, and I have a y-intercept of 2 square root of 3 pi plus 4. So here is my b, and here is my m. Is it right? Well, you could plug into the homework system and hit submit, or you could check it yourself. So let's check it ourselves, because on the test, you're going to have to check it yourself. How would we check it? We would graph it. So let's get rid of this one and just rewrite this one. So 8 times the sine of x is our function, which is much taller. And I am interested in the point pi over 6, comma, f of pi over 6, which should be 4, right? Good. All right, so there's my point right there. Now I'm going to test my tangent line. I think my tangent line is y equals 4 square root of 3. And again, GeoGebra in the bottom has a calculator button where you can get square roots and stuff, times x. And then what was next? Minus 2 square root 3 times pi plus 4. Ooh, did I screw something up here? Or did I mess up? I have an error. That ain't tangent. Okay, where, oh, I forgot about the 3 in the denominator. Oops. So again, I reduced here, and that's divided by 3 right there. So I missed that in my messy handwriting. So that goes over here. 3 anywhere you like in there. Ah, there we go. That looks better. So now I can see that that looks pretty tangent there. If you're not sure, one nice thing about GeoGebra that I like is I can adjust the graphics by compressing, stretching in different ways. Yeah, that looks pretty tangent right there. Okay, so good thing I checked my answer, otherwise I would have got it wrong the first time. So enter your M, enter your B, and don't forget to find ways to check yourself. Thank you, that was a fun one. All right, other questions? Is that the last one? Is there anything else I thought was really cute? That was cute, did that one. Oh, that's a cute one right there. Number 7, we might come back to that one. Number 6 is nice too. I think I like 6. Let's take a look at number 6. And then we'll move on. To new page, please. All right, so the reason I picked this one is I see the tangent divided by the secant. I'm thinking, I wonder if this cleans up a little bit. And so before I take a derivative, I'm just going to do a little algebra, because sometimes if you can write the function different, it's easier to take the derivative. Here, looking at it, I have both the product and the quotient rule. So I'll do a little algebra and then do it back the way it is and see if there's much of a difference. So the algebra I'm thinking about here is I'm just going to pull the 5x squared out. And then tangent is sine over cosine. And then that is divided by the secant, which is 1 over cosine. And dividing by a fraction is multiplying by the reciprocal. So I can rewrite that by multiplying by the cosine of x. And then I can see, oh, okay, so the cosine here divides with the cosine there. And this should be the same function as 5x squared times the sine of x. And hey, that's way easier. You should double check that you did things right. So if I graph the original and that, I should see that they're the same. So I'm just going to double check that. Back. Let's get a new calculator. So the original function, 5x, I think was equal to 5x squared times the tangent of x divided by the secant of x. So I got that funky function there. Interesting. And then I'm going to compare that with, let's call it g of x, which I believe was 5x squared times the sine of x. And it looks like the blue one sits exactly on top of, the green one. So they're the same thing. So I did my algebra correctly. These two are equivalent. Second one's easier to take the derivative of, and so that's what I would do. So often when I'm playing with trig, before I even jump into the derivative, I think, is there an easier way to write this? And now I'll take the derivative both ways just for fun. So the red way, so that's f of x. I'm going to find f prime for this red version is just the product rule, which says take the derivative of the first function, 10x, multiplied by the second function. Add the first function, don't mess with it, then take the derivative of the second, which is cosine of x. And there's not much I can do with that besides, say, factor out a 5x, which leaves 2 sine of x plus x cosine of x. And not much I can do with that right there. So I think that's as simple as it gets right there. All right, let's take it the other way where we have to use the product and the quotient rule. So this one, is the way I think the author of this problem meant us to do it. So the derivative of the top is what the quotient rule says to do. So I'm thinking quotient first. The numerator is a product. So the derivative of the top, I have to do the product rule on that. So parentheses for the derivative of the top, that would be take the derivative of 5x squared, which is 10x, and then just multiply by the tangent. And then add that to the derivative of the first function, 5x squared. Derivative of tangent is secant squared of x. So that's the derivative of the numerator multiplied by the denominator. And then now I'm back into the quotient rule. Quotient rule says then subtract the numerator, 5x squared tangent of x, times the derivative of the denominator. Derivative of secant is secant tangent. All divided by the secant squared. Okay, so again, just how did I come up with this here? First, I was thinking about the quotient rule, and the quotient rule says take the derivative of the top. So the derivative of the top requires the product rule. So here's my top right there, and I took the 10x is the derivative of 5x squared times the tangent. We don't mess with that. Then add the first function, 5x squared, times the derivative of the next function, which is secant squared. So that's the derivative of the numerator. So the quotient rule says take the derivative of the numerator times the denominator minus the numerator left alone times the derivative of the denominator. Careful, right? And then we have to do some distribution, and a whole bunch of stuff must clean up here. So we got to distribute that secant, and then we can combine terms or powers here. So that's going to give me 10x tangent of x secant of x from the first distribution, and then plus 5x squared secant cubed of x. And then we have minus 5x squared tangent squared secant of x. Okay, all of that is over secant squared of x. What can we do with this? We have three terms. Every term, let's see, pick a different color, has a secant in it and an x in it and a multiple of 5 in it. So I can factor out a 5x secant of x, and remember the separators here, right? We have a plus there and a minus there. So I have three terms in the top from which I'm factoring out 5 secant. So take the secant, a 5 and an x. So there's a 2 here and a tangent from the first one. Second one, I took the 5, I took an x, so there's an x. I took one of the secants, so there's a secant squared. And then that's it. Over here, I took a 5, I took an x, so minus x. I took the secant and I get a tangent squared. Ooh, I see something beautiful. All over secant squared. And then this is going to clean up quite a bit. This, let's see, blue, this secant divides with the square, leaving just a secant in the bottom. And then here, if we factor out the x, we're left with secant squared minus tangent squared, which we double checked earlier. Secant squared minus tangent squared is 1. So that cleans up quite a bit. So you're going to get, hopefully, a workout on your trig identities here. So this whole piece right there, once I factor out the x, is just 1x or just x. So now I have in the top 5x, that canceled. And I have 2 tangents, that's still there, right here. this is just 1x, so plus x divided by secant. Oops, missed the c, secant. And then if we applied a little sine cosine action to this right there, I think we're likely to find, oops, all of this right here. But I'll leave that as an exercise to you if you wanted to take it a step further. Yeah, so Kelsey says she prefers the first way here, and I do too, but sometimes when I get a problem like this, I don't realize I could simplify it first, right? I just look at it and I just start jamming on the derivative. So that's the problem. Do you notice that you can clean a function up before you take its derivative? And here you can clearly see it's worth it if you can, right? So this is just, you know, good wisdom for the future. If we have to take a derivative of a constant function, we should say, hey, could this function be written easier? So we do a little algebra. If it can, cool. If not, oh well, grind. Just pay attention to what you're doing. And again, I could also check these two answers by graphing them, see if the graphs look the same. Or, you know, do the lazy way and just put submit in the box, you know, on the homework problems. All right, so let's see. We are going to try something else. So we're going to play, oops, I didn't want that button. I want that button and a new recording, please.